let's look at how to use Excel to forecast a time series using the classical decomposition method known as the multiplicative model. So here we have the data that we want to forecast. It's quarterly data over 4 years on the sales of a particular product, measured in thousands of, well, let's see, this is thousands of pounds, or it could be thousands of units sold, it doesn't matter specifically here. And we want to forecast for the next year, year 5. And now, in this decomposition method, what we want to do is precisely that. We want to decompose the pattern in this data into its various components, specifically the underlying trend and the seasonal variations around that trend. And then we recombine them to make a forecast. So the first step here is to find the trend in the data. Now the classic method of doing this is to work out what's called a centered moving average. That is, we average a certain number of values, in this case 4 since it's quarterly, and center that average. We then update it by dropping the first one, adding the next one. So the next 4 that we average are those 4 there. And then again we drop the last one and add another one. So the next 4 that we average are those, and so on. Now, in fact, since we're using quarterly data here, we're going to average over 4 periods. This is arbitrary. You could use 3 periods or 5 periods or whatever, but it makes sense here to use 4. We can't directly center it because it should go at the 2.5 position, which is there, which of course is on the border. So we have to use a what might be called a double method. And what we do therefore first of all is find sums of 4 values. So, and the first one goes alongside the third value here. So that into here alongside the third of the first 4 values, I'll put the formula to find the sum of those first 4 values, like that. Now, if we copy this formula down, because we've used relative references, it's basically saying add up the values which are 1 to the left and 2 up, and then 1, 2, 3, 4 down. When I copy it down, it will do all the rest correctly, as you'll see. So let me drag this down. Now it only has to go to there, of course, so that the final sum here is the sum of the final 4 values, which should be D14 to D17, which is correct. So the formula has updated correctly. The next stage is to find sums of pairs of values, again overlapping. So firstly those 2, and then those 2, and then those 2, and so on. So into here I'll put the formula again, sum these 2 here, like that. And then again, because I'm using relative references, it will adjust accordingly when I copy it down. And again, be careful, only drag down to here, so that the last sum is the sum of this pair here, E15 to E16, which is correct. Now, to find the underlying trend, we divide this total here by 8. Not 4, we are finding effectively the average of 4 values, but because we had to do it in this way, this is the sum of 8 values. To find the average, we need to divide by 8. So I will put in the formula to divide this by 8, which gives me the trend value, first one, and then I will drag down to do all the rest. Okay, so that's the first component of the pattern, the first decomposition, the underlying trend. Now I want to find the seasonal variation around that trend, and to do that I need to, as it says here, divide the actual data by the trend figure. so that what's remaining is the seasonal variation plus, in fact, any irregular random component. So I'll do that here. So it's going to be sales, actual value here, divided by the trend, which gives me this value here. I'll just reduce that down to a couple of decimal places. Don't need all those there. Remember, of course, that has not chopped the decimal places off internally, it simply changed the display. Now if I copy this down, this should do the rest. So those are my seasonal variations around the actual trend, and of course they will vary depending on the quarter and the year. What we're hoping to find is that the variation in one particular quarter from year to year is roughly similar, and of course of the same sign, so that in fact they'll all be positive here given this method, but so the same size, so that we've got a consistent pattern. But because they differ, what we need to do is to find the average of them to give us the typical variation in that quarter. So what I want to do here is to copy these down to a little table here and then average them. So taking quarter one first of all, so we've got that one there, and then that one there, and that one there. Remember, you can select cells which are not adjacent to each other in Excel by selecting the first one and then holding down Control as you select the others. So those are the quarter one. Now I'll copy those and then paste them down here like that. Now let's do quarter two. The first one is this, then this, and then this. Let me do the same again, copy and paste down here. Those are the quarterly variations in each quarter in each year. I say we're hoping that they are similar. In fact, they are very similar, so this suggests a very regular pattern which should make forecasting much more accurate. Let me find the average of these. So that's the average of the variations in quarter one. Let me put that in bold. Now I can simply drag across, of course, to do the others. So those are the average variations. Now, in fact, you should check that these add up to 4. 4 in this case is because it's quarterly. If we were using monthly data, there would be 12 of them, and they should add up to 12. If not, we have to adjust them. So let me find the sum of these 4 values. And as you can see, it's virtually 4. It's close enough that we don't really need to adjust them here. But if they were quite different from 4, you would need to adjust them so that they added up to 4. Okay, now so these are the quarter variations, the typical variation each quarter. I now want to transfer them back up to here, into this column for the seasonal variations. And they will repeat, of course, from year to year. So to do this, I'm going to highlight them, click copy. I want to paste them from a row into a column, so I need to transpose them, and I also only want the values. Now the way to do that is to use paste special, so I'm going to right click here in the first, where the first one will go, right click, choose paste special. I want simply those values. I want to transpose them. There we go. Again, let me reduce down to just a couple of decimal places. Now I need to copy these down a few more times so that, because they are the same of course from year to year. So I'll copy and then paste, copy and then paste. And I also need them in the forecast year because they're going to be used to generate the forecast. So those are my seasonal variations. So that's the second component of the pattern. So we've decomposed it into inline trend and variations around that trend. Anything left over will simply be some irregular, some random fluctuation. Now, how do we generate the forecasts? Well, to do this, I first of all want to find the deseasonalized values, which means using the seasonal variations to remove the seasonal variation from the data. And to do that, I need to divide the actual data by the seasonal variation, so that what's left over is simply the underlying trend plus any irregular component. These are the deseasonalized values, so let me do that. So it's the actual data here divided by the seasonal variation. Let's put that down to 2 decimals again. One more, couldn't see it, so I have to guess. Okay. Right, now let me copy down to do all the others. Well, only down to, in fact, there, because of course for this there's only data for up to year 4. Don't go down to here because there's no actual data here. Of course, this is what we're trying to ultimately determine as our forecast. Now, what I then want to do is to fit a line of best fit to these deseasonalized data to give me some an underlying trend there which I can push forward to make forecasts. So what I need to do is to find the line of best fit through this data. Now, the easiest way to do this, you could use the built-in regression facility, but it's easier, since it's only a single variable, to simply draw a line graph and then add a trend line and find what the equation is. So what I want to do here is to draw a line graph of this data here. There we go, a simple line graph. I'll put it over here, of the deseasonalized values. I could add the proper category labels here, the year and the quarter, but I don't need that. I simply want, because I've got enough now, to add a trend line. And I also want to show the equation on the chart. So it's a linear trend line, line of best fit. As you can see, it's appeared. Display the equation so that I know the parameters. There they are. Let me just move that here so we can see it better, and I'll increase the font size. Okay, so this tells me that the line of best fit through this deseasonalized data has an equation y being the deseasonalized value, plus 0.1471x, that's the slope. 1.7x, of course, is simply the time period here, going from the first quarter here is 1 and then 2 and so on, with an intercept of where it would cut the vertical axis of 5.0966. So I want those values on the line of best fit, which I'm then simply going to extend into the future. So what I need to do here is, if I move this out of the way now, what I need to do is to calculate these points on the line of best fit using the equation, put them into here, and then keep on going into the forecast period. I'll then simply multiply together this forecasted trend with the seasonal variation. That gives me my forecast. Now, how do I get these values here? Well, notice these are given by the equation. Y is the thing I'm trying to, is the forecast value of deseasonalized. X, in this case, is simply a variable that goes 1, 2, 3, 4, 5, 6, so, and so on. Just a simple sort of time variable. So what I've done over here is include a variable here. This is why this variable is here, which simply runs from 1 through to 16, and then in fact through to 20. So it gets me into the forecast period. So I can use these values for my X in here, and therefore find the values that are on this line. Okay, so in here I'll put the formula here, so it's equal to, so let me just check here. Okay, so it's equal 0.1471 times X, which is this one to begin with, plus, and the intercept is 5.0996. So that will give me this first point here on the trend line, which, as you can see, should be very close to the actual value. Of the deseasonalized, which is 5.15. It's slightly above that, you can see. So again, let me just reduce that down. The display, I think that's 2. Yep. Okay, now if I copy this down, it will then use X of 2 and then 3 and so on. So that should give me all the lines that are on this. So effectively what I've got here are the points on this dotted line for any given value of X, any particular period, ranging from period 1 up to 16. Now I can then simply continue dragging down here to continue with the formula, and it will use the values for the forecast period and in effect extend this line into the future. Like that. Let me put these in red to remind me these are in the forecast. Okay, so that's how I push the trend forward in effect. And to make a forecast, I simply need to multiply this forecasted trend value by the corresponding seasonal variation. In other words, recombine the two elements to give me my forecast. So again, I'll just move this something out of the way. So here we have, actually I'll do it for all of them, even though these, of course, these forecasts here from 1 to 16 will be in sample forecasts. Really, it's the outer sample what I'm interested in, but by finding these, I'll be able to compare the forecasts with the actual data and give an indication of how good those forecasts are. So let me do that here. So it's a forecasted trend times the seasonal variation, the typical variation for that quarter. Again, putting this down to 2. I think that's enough. Yep. So all the way down now. There we go. And these therefore are my actual forecasts, the ones I'm really interested in, the future forecasts. Okay, so that's the forecast generated using this method. Now we can just finally draw a graph here just to see how these forecasts look from the actual data. So let's finally draw a graph. I will draw first of all the sales, the actual data here. Notice I need to go into the forecast period so that when I put these on, they'll appear in the right place. So if I now include the, try start again with that. So copy the here, hold down Control, forecasts. Okay, let's put a nice line graph. And there we are. So you can see the actual data here in blue and the forecasts, and look how close they are. Now let me just tidy this up to make it look better. So if I go into design here, select data, I can put in the proper axis labels, which are these ones here. So that's better. And also, rather than saying series 1 and series 2, of course I want them to have the correct names. So series 1, of course, is the actual data. So if I go to that one here and click edit, and the series name, I can click that to put that in. As you can see, that's now correct labeled. And then finally, series 2 is the forecast. So let's click there, click edit, choose forecast for the series name. And then we have a nice chart showing the, I can also need to edit the title, but I'll not do that here, showing the actual data, the in-sample forecasts here, which are very close, which of course suggests that our actual outer sample, our future forecast, should be, hopefully, assuming the pattern continues, should be fairly accurate. Okay, so that shows you how to use this multiplicative model.